Some time ago, I did an analysis of the downward acceleration of the roofline of WTC-1, the north tower of the World Trade Center. I was only able to track the motion through the first few seconds while the roofline was visible above the debris cloud. I found that the drop of the roofline occurred with sudden onset and underwent a uniform acceleration, 64% of the acceleration of gravity. I started the current project to explore whether the same acceleration continued all the way down or whether it changed as the destruction moved down the building. I found the answer to that question, but along the way I noticed something else that is perhaps even more intriguing. We'll come to that unexpected observation at the end of this video. One of the most conspicuous features of the destruction of the Twin Towers on 9/11/2001 was the rapid rate of fall. For most people, their intuition tells them that buildings do not fall in on themselves, especially that fast, in any kind of natural event. Intuition does not have the last word in a situation like this, but blindly accepting the contrary pronouncements of authority figures is little better and perhaps worse as a guide to the truth. We need to look for ourselves. It is commonplace to hear that the Twin Towers fell at freefall speed. As a point of clarification, the rate of fall is characterized by acceleration, not speed. This is more than just a vocabulary question. It involves a basic concept. So let's pause for a little demonstration. One tool I use for studying motion on video clips is a program called Tracker. It's part of the open source physics project, and it's freely available on the internet. What I'm going to do here is drop a soccer ball and record its motion. To do that, I have to add marks on each frame. The program collects the positions from the pixel locations and the times from the frame numbers. It displays the data in a table and a graph. This graph shows the vertical position y versus time t. What results is a picture of the motion of the ball spread out over time. To translate the pixel positions to actual measurements, I have to calibrate the image by marking something of known length. In this video, I'm holding a meter stick, so by marking the ends of the meter stick, the program can figure out how many pixels on the video make up 1 meter in the real world. Another thing we can do is look at other quantities. For instance, if we plot the vertical component of the velocity versus time, we get a graph that looks like this. Note that the position versus time graph for freefall is in the shape of a parabola, and the velocity versus time graph is a straight line. What's going on here is that when I let go of the ball, the velocity starts out at 0 and increases downward by equal amounts in equal increments of time. That produces a linear graph. Free fall would be a smoking gun for explosive demolition because it would indicate zero resistance. Building 7 fell in actual free fall for over 2 seconds. NIST has grudgingly acknowledged this in their final report, but has refused to even address the obvious implications. In my earlier video, I measured the rate of fall of the roofline of WTC-1 for the first few seconds while it was visible, and found that it came down with constant acceleration, 64% of the acceleration of gravity. In that video, I showed the fact that the top section of the building accelerated right through its collision with the lower section. It is also a smoking gun for explosive demolition. Watch the video Downward Acceleration of the North Tower. I won't repeat the argument here. In that video, I noted that if the rate of acceleration persisted, the tower would fall in 11.5 seconds. Jim Hoffman on his website 911research.wtc7.net does a thorough analysis from several lines of evidence and concludes that the total time for the North Tower to fall is approximately 15 to 16 seconds. I wanted to understand the rate of fall beyond the first few seconds. Measuring the motion of falling clouds of debris is difficult, so rather than a direct measurement, I wrote a program to put 2 sets of markers on a video of the falling tower. Both start at the height of the roofline. The blue mark descends at free fall. The red mark descends at 64% of free fall. As we run through the clip, it is clear that the top of the debris cloud does indeed lag behind both marks. Even the heavy falling debris near the bottom falls at less than free fall because it is meeting air resistance. So much for the original purpose of this project. However, along the way I noticed something else. One feature is actually keeping up with the red mark, the original downward acceleration of the roofline. That's the sequence of ejections at the lower right on the west wall of the tower. That means this wave of ejections is the fastest moving feature in the building's descent. If anyone still believes these are naturally occurring puffs of air, caused by some internal process, such as collapsing floors, they would need to explain how such a process could propagate so fast within the building, nearly keeping pace with the heaviest debris falling only through air just a few feet away. If one assumes the floors collapse to blow out this much material in the leading wave of ejections, one would also have to explain how air pressure could be built up and maintained higher in the building for the other waves of ejections that follow. The fact is, strong, focused ejections are occurring on multiple floors simultaneously. The theory that these are simply air being squeezed out defies both common sense and any kind of honest analysis. The most reasonable way to account for the rapid wave of ejections is to recognize them to be a timed sequence of explosions designed to destroy the underlying structure of the building, top to bottom. Such a sequence would not be limited by physical conditions in the building. The downward motion of the explosions is merely a pattern designed purely for appearances, to mimic a natural collapse and to stay hidden under the canopy of the falling debris. If this was the intent, it was not accomplished successfully, as we can see. Perhaps the reason the leading wave of explosions propagate down the building at the same rate as the initial acceleration of the roofline is they were timed that way on the assumption that the building would continue to fall at the initial rate all the way down. That last point is just a speculation, of course, but the measured outcome is not.